Example 1. Find the value of each of the 6 trigonometric functions of an angle Q in standard position whose terminal side contains the point -3 to -2. So first of all, standard position simply means that we start off at the positive x-axis. So we're measuring starting here, and then we go around that, so we have basically our radius is the center of 0, 0. Our center is 0, 0, and we're going to rotate counterclockwise around the x-axis, or around the xy axis. So this represents 0 degrees. We're measuring that direction. It says the terminal side contains the point -3, -2. So 1, 2, 3, 1, 2. That's just basic graphing of a point, and that's point P. They're calling it. Right, now, as far as measuring this vector is concerned, or drawing this vector, I'll make that my vector. Dang it.
It's not cooperating.
It's not where I want it to be. Hold on. Make that just a smidge bigger so it's easier to grab. Okay. So, if I'm starting at 0 degrees standard position and I go counterclockwise until my vector goes through that point. Okay? It doesn't specify, I mean, it doesn't have to be right at that point, just as long as it goes through that point. Okay, that's what we're talking about. So, this right here represents my actual angle for my vector, theta. So that's all that there is to drawing this. Send that backward. There we go. That the point -3, -2 is being intersected by my vector. All right. It's not specifying how long the vector is. It doesn't really matter. Okay. But we want to find the value of the 6 trig functions. Now, I'm going to use this point as a point of reference because it's specific. I know exactly how far I'm going in both directions. And what I want to do to handle a problem like this is consider that if I wanted to figure out the value of the trig functions, I need to, basically I'm trying to find all the stuff about this angle here. We'll call this alpha, this reference angle here. And if I were to draw in a horizontal and a vertical line to create a right triangle, that helps to establish measurements on this thing. P down there. Okay. So what I want to do is look just at that right triangle and focus just on that. And if it makes you guys feel better, again, it doesn't matter how long this thing is, but if some people prefer this to be just how long it is. So we're just looking at the right triangle. So the blue sides are the legs and the green side is the hypotenuse that we're dealing with. And what I want to get across to is this. The length of this is 3, right? But which direction are we going? Going left. So we're going to go -3. And the length of this other leg is 2, but we're going down, so that's -2. Right angle's right here, right? So horizontally and vertically, you got to worry about direction. Which direction did I go to get to that point? And it's real easy to know right here. Whatever these signs are, that's what signs go on the numbers. But just again, us establishing that if I go left, it's negative. If I go down, it's negative. If I go up, it's positive. Right, it's positive. All right. The thing I don't know is the hypotenuse. Let's just call it x to give it a name. But Pythagorean theorem still works, right? And if I did the Pythagorean theorem, x squared is equal to 2 squared plus 3 squared. When you square things, they become positive every time, so keep that in mind. Those are always positive regardless of the size of the legs. So x squared is going to equal 13, which makes x equal the square root of 13. Now let me just make one note here. Important note. Hypotenuse is always positive. I'll underline always a couple times, a couple exclamation points. Hypotenuse is always positive. The legs can be positive or negative depending on direction, but the hypotenuse is always positive. Never ever negative, not even once. All right. Now, what we're trying to figure out is the trig values of this vector, okay? And we have this angle right here is the reference angle for that vector. And if I go across the triangle, that represents opposite side is -2. The right angle's up in the top left corner, go across, the green side is the hypotenuse. When you do these problems, the slanted side is always the hypotenuse. And then, of course, the third side would have to be the adjacent then. And just like that, we've got our angle, we've got our sides identified. We simply apply SOHCAHTOA to find sine, cosine, tangent. So if I just start off with SOHCAHTOA, over here, that's sine alpha equals, actually angle Q is what they're calling it, right? They call it angle Q. So sine of Q equals something, cosine of Q equals something, and tangent of Q equals something. All right, so sine is opposite over hypotenuse, so -2 over the square root of 13. And just like we did last chapter, I want to write it like that, and then I want to fix it. So in my work, I want to have it like that so I can fix it. Multiply top and bottom by the square root of 13, I'm going to get -2 times the square root of 13 over 13. If I do cosine of Q, cosine's adjacent over hypotenuse, that's going to be -3 over the square root of 13, which gets me, multiply top and bottom by the square root of 13, -3 times the square root of 13 over 13. And tangent of Q is opposite over adjacent, that's -2 over -3, which is perfectly fine. I would prefer to call it positive 2/3. All right. Once I got my three normal trig functions, the ones I'm used to, sine, cosine, tangent, then I want to do the reciprocal functions. And again, I want you guys to become familiar with the reciprocal functions, which one's which. Sine's a reciprocal to cosecant. Cosine's a reciprocal to secant. And tangent's reciprocal to cotangent. Be kind of nice if sine and cosine were reciprocals, and let's say they had some different trig functions, let's say cat and cocat, and then tan and cotan. It would be nice if they did it that way. They didn't know. So anyway, they came up with these guys. But it'd kind of be nice also if cosecant was reciprocal cosine. It seems like it might make sense, but I don't know. But I wasn't there when they decided to name things, so I didn't get to go to the meeting. But I'm reciprocating now. I can reciprocate the end result, but it's easier if I just reciprocate right here. So negative square root of 13 over 2. Again, reciprocating this over here would be easier. Negative square root of 13 over 3. And if I reciprocate 2/3, I get 3/2. So I got my sine, cosine, tangent, cosecant, secant, cotangent. I got them all identified, figured out. And again, the point establishes where you are. Directional things get you correct signs. Okay, so again, back in 5.2, these triangles, we always created a positive sides. We have everything positive. Now we got some negative, we got some positive, and it depends on what quadrant you're in to establish what sign each thing is going to be.